Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to Proving Triangles Similar. And I know you might be hearing that word proof and going, oh, yeah, why do I have to do this? Okay. We just want to know what the triangular similar mean. And again, anytime we talk proofs, we're just kind of talking about logic. So let's go ahead, and I'm going to go ahead and take these two triangles and I'm going to drag one on top of the other. Okay, so we're going to bring DEF down. And I said 30 degrees here, 90 degrees. This was D, this was E, this was F. Okay? And I know I didn't draw it the exact same. I'm just kind of estimating here. I'm going to bring this down and I'm going to draw it as well. Now, angle D and angle A are the exact same size, so I want to go ahead and draw that way. So, and it had that 90-degree angle as well. So A, B, C. So now that I've done that, I can actually see, hey, we happen to have parallel lines because the angles are the same, cut by a transversal, and so we know that parallel lines happen to create. So because those are parallel, we happen to notice that here's parallel lines cut by a transversal, so these angles would be corresponding, and so they would be congruent as well. But we knew in the beginning we had two congruent angles, the 30-degree and the 90-degree, and that's how we could line these up so nicely and create parallel lines cut by a transversal, which means we have a dilation, because you notice that this is a point of dilation, and if you've watched my dilation videos, you know that we drew those lines through all the points. Yes, absolutely. The center of dilation just happens to be a vertice. So what we can see here is that we could also go through, and because of the dilation, we know we have a scale factor. AB would be congruent, would be related to AE. So we could say AB and DE, and we could AC and DF, and these would be equal ratios, or it would be your scale factor. So we could go through all of that and we could talk about the similarity based off of angle. So knowing two angles is enough to prove two triangles are similar. So angle, similarity, or A, bloop. Okay? That's all you need is two angles, and you know they're similar because of, now we are talking for triangles, we're not talking about everything else. If you don't know anything about your angles, your second option is to have side, side, side similarity. Okay? With side, side, side similarity, or SSS similarity, not to be confused with side, side, side congruency. Let's say you had a 3, 4, 5 triangle and a 20, 12, 16. Now, you might have noticed that I might have reflected it, flipped it, things like that. But the shortest side is 3, the middle side is 4, and the longest side is 5. Here, the shortest side is 12, the middle length is 16, and the longest length is 20. Do you see how you could take this top row and multiply it by 4? and you would get the bottom row. Okay, that's a scale factor. And it depends on which one, like this to this, going bigger, your scale factor is 4. Going smaller, your scale factor is 1/4. So just keep in mind which way you're going. But that would be a side, side, side similarity if you could prove that all 3 parts of the triangle had the same ratio. Okay. Your other option is side angle side similarity. Okay. Okay. So you get side angle side similarity is also enough to prove. And I'm not going really in depth into why these proofs work, because we could make a complete video about that. But five, 10, 9, 18, and 30 degrees, 30 degrees. So if we were to take this and bring it on top, then we'd have a angle that matches up, right? So we could do the whole verifying of all the segments to make sure, but we have that point of dilation. Because we have that point of dilation, now we have congruent segments because this segment was dilated the same as this segment, and this segment was dilated the same. So that means the third one would also have to be the same. All because we could drag this triangle on top of that triangle. And we can see our scale factor is 10 to 5, which is equal to 18 to 9, which is equal to 2. We now know our scale factor to go from the first shape to the second shape is times 2. If you thought of it the other way, depending on the directions, that's times 1/2. So going bigger is times a number bigger than 1. Going smaller is timesing by a fraction between 0 and 1. Okay? So when it comes to sides, you have to have all 3 sides or 2 sides in an angle. Now, so when proving triangles congruent, we had angle, side, angle. Keep in mind, we don't need angle, side, angle congruency in this case because we already have angle, angle similarity. So we don't need an angle, side, angle similarity because angle, angle similarity is sufficient. So please keep that in mind. All right. So I'm going to give us an image here. It is not drawn to scale. Please keep that in mind. I know it looks like a perfect little bow tie. It is not. So we have J, K, L, M, N. This is 1. This is 75. This is 10. These segments are congruent. These segments are congruent. So based off this, can you find MN, assuming that I actually drew this correctly? I know I did not draw this correctly because I wanted to be able to see the details. Could you find MN? If so, what is it? Okay. So first of all, can I find it? Well, what do I know? I know because I have a isosceles triangle. I know that this is congruent to this and this is 75. Over here, I know I have an isosceles triangle. So this is congruent to this. And so since this is 1, this is 1. but I haven't really related anything on the left, anything on the right. Okay. So what do I got going on here? Well, I happen to know that this angle and this angle are vertical angles, and vertical angles are congruent. Okay, so because the vertical angles are congruent, in other words, the measure of angle JKL or JL, okay, is equal to the measure of angle MLK or MLN. Wow, I got letters all the way over the place. And because JL to ML is equal to KL to NL, and those are both equal to 75 over 1, sides, right, with the angle between the sides, because I used this pair here, and then this angle, and then this pair here. So I have side, angle, side. I now have side, angle, side similarity. And I now have a scale factor. I know that this triangle is 75 times bigger than this triangle, right? Because I would have to multiply this by 75 to get to there. I'd have to multiply this by 75 to get to 10. So MN multiplied by 75 is going to equal 10 because of our scale factor. So I'll divide by 75. And it makes sense that it's small because 10 is smaller than 75, so we need something smaller than 1, right? And if we reduce that, we get 2/15. So 1, yes, they were similar, and therefore MN is 2/15. So if you didn't like that version, you could have also said 75 over 1 is equal to 10 over MN. And then cross product, and you're going to get the same math. 75 times MN equals 10 times 1. So cross products, however you want to look at it. But all you need is either angle-angle similarity, side-side-side similarity, or side-angle-side similarity. One of those three is going to get you there. It's easier to prove two things are similar than it is to prove congruency, I think. But then again, you might have a different opinion because everyone feels about math a little differently.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.